Hello everyone, my name is Nate Polarize, and I'm here today to talk about my first project of the semester, the block maze. So in the background, I have a video running just so you can see the operation while I talk. So the whole point of the block maze is to move the metal block around the square as fast as you can without it getting caught in any of those, there's like inside indents, because if it gets caught in there, it will need manual assistance from a person to get it out of there. There's no way to get it out without a person moving the block manually. And as you can see, my project is more of a hands-on one than the programming, so it was a lot more wiring and stuff. On the right side, you can see the pneumatic systems, and there is a manifold that is fed air, which then feeds solenoids that are controlled by the PLC program, which sends air to the pneumatic pushers, which you can see two at the top of the screen. There's one on the right middle and one in the bottom left. Three of them push and one of them pull to move the block around the square. And there are sensors on the cylinders that can sense when the cylinder is in a certain position. So you can place them on the cylinder whenever you want, and when the cylinder is right on that sensor, it will tell you. It is a inductive sensor, pretty much just seeing the inside of the cylinder and can see the endpoint of it. Now that you have a very basic understanding of what the project is supposed to do and how it works, I'm going to show you my progression pictures that I took throughout my time working on this project. So this is my first progression picture. This is what it looked like on day one when I walked in after Christmas break, and it was pretty much just a mess. This is my second one. As you can see, I cut off about a foot on the top of the board and rearranged it a lot, so it's starting to look a lot better. Move some stuff, other stuff around. This is my third progression picture. I started to do the wiring for the safety relay, so you can do the buttons and reset there. This is my fourth progression picture. Here I had the wiring for the safety relay complete, and then I started running I/O points from the terminals on the right to the terminals on the left. And then here is where I started wiring to my sensors to the terminal blocks and some buttons inputs mainly. This is when I completed all my wiring. So I finished the outputs and the inputs from that last picture and had all my wiring done. And on this one, this is my completed layout and everything's wired, everything's where it's supposed to be, and I have my pneumatics hoses hooked up. The next thing I am going to be talking about is my CAD drawings. This first one here is a representation of the physical layout and where things are physically on the project. The first thing here on the left side is the pneumatic manifold and solenoids which feed air to the cylinders. The thing above it is the pneumatic filter, regulator, lubricator, and dump valve, which feed the other piece, the manifold and solenoids. And then you got the wire duct around the outside. You have the pneumatic pushers. You got four of them. Starting on the left is one, bottom left is two, bottom right is three, and top right is four. And then you have your buttons in the bottom left. And under the pneumatic pusher in the top right, you have your disconnect and power supply. You have more terminal strips at the bottom right, where that little strip is. You have your point IO on the right side, and that is all the parts for that one. The next one is the electrical. That first piece is the first input point IO rack or point IO card. This is a second point IO card. All the input ones are 4 slots, so they can have 4 inputs. That was number 3, and then this is number 4. Now next we have the outputs. This is the 5th rack, but it's the first relay output. These are also 4 slot outputs. So that's number 1 right there. The next one to the right is relay output card number 2. This one is relay output card number 3. And then this last one is a analog input card. It has 2 channels, but I'm only using 1. So, and that has a sensor connected to it. And now this next part is the power circuit for the project. It has a disconnect switch, which I showed you in the physical drawing, layout drawing. Then it is through the power supply and then connects to the point IO and other devices. The next one is the power supply for the trainer, which has my PLC, Ethernet switch, and CompactLogix PLC. This final piece is the safety relay. It has 2 relays on it, and they are used to have extra safety and redundancy to it. I'll have a manual printed this, so this drawing is kind of hard to understand if you don't know what you're looking at. But this part over here is the pinouts and terminals for those extra 2 relays on the safety relay. This final drawing is my pneumatic drawing. So first there is the pneumatic layout drawing with the 4 pneumatic pieces, the 4 cylinders, the manifold, and the 4 double solenoids. And it shows where all the hoses go and what side of the pneumatic pushers they lead to. So the other part on this drawing is this pneumatic. This is the real pneumatic drawing. It's not the layout. It shows like the valves and all the pneumatic symbols for it and where each one goes to it. So the next thing I'm going to show you is the Ethernet IP diagram. On the right side I have my 5-port Ethernet switch, my panel view, and my CompactLogix PLC. This is all on my trainer. On the left side I have 2 switches, a patch panel, and my point IO. The next thing I am showing you is steps on how to get the block maze to run. So this is as if it was just stopped and left there by someone. So first you want to make sure the e-stop system is good. You pull out that e-stop and click the reset. And the next thing you should always do first is put it into hand mode and click start, which will reset all of the solenoids to their resting position. The next thing you want to do is place the block in the bottom left intersection. On the video, it's top right. Then you switch it to auto mode and click start. What this will do is it will start pushing the block all the way around and pulling it around the block maze, and this will just continue to happen until something, either a fault or you stop it or an emergency happens, anything like that, to where causing it to stop. So here I'm going to let it go around a couple more times, and then I am going to click the stop button. So what that does, it just automatically stops it there, and I'm going to move the block here to show you again. So to reset that and restart it, you put it into hand mode and click start, and it will move that back to the resting position. That works if it stops anywhere. It does not matter where it was stopped, it will work. And then you just obviously put it back to auto and click start again. And it will start moving around the square again. The next thing that I'm going to do is hit the E-stop. So I hit the E-stop there, and obviously I'm moving the block out of the way again and resetting the E-stop circuit and switching it to hand again. And then click start, and back it goes into resting position. So obviously I'm putting the block back, switching it to auto, and click start again. So what I'm showing here is one of the Watchdog fault timers, so that you can see with the yellow wire there's a inductive sensor there that will keep track of when the block goes around the maze, and if it doesn't come around in a certain amount of time, it will fault. So right there you can see it faulted. And how to clear that fault is you switch the selector switch to off and then hold the stop button for 3 seconds. And there it stops blinking. Then I can put it back into hand, put everything back into resting position, and that is good to go for next time. So the final thing I have to show you today is the HMI for my project. As you can see here, it's kind of blank. So right now I'm signed in as the janitor, so you can't really see anything except for some just very basic lights and air pressure and lap count. So I'm going to sign in here as the operator, and it's capital O, and then like operator with capital O, and then capital O lowercase p for the password. So when you log in there, you have a bunch more buttons show up. You got all the basic start, stop, hand/reset, off, and auto. And then top right, you have your manifold and pushers section. Those just take you to the other pages. So it's the same operation as before with how to work the system. You can just, the start here replaces the start button on the physical start button. The stop obviously replaces the physical stop button. Hand/return is the hand mode. Off is obviously off on the selector switch, and auto is obviously auto on the selector switch. So you can see the lights coming on when the safety relay is enabled, is that top left one. You can see the dump valve if that's on. The air pressure you can see the lap count. You can see if the machine is enabled, and then you can see if the machine has a fault. And when you're signed in, you can, as an operator, at the moment, that is all you can see. The lap counter went to 4. And then here you can see all your solenoid valves, whether they are being activated by the program or not. If they're green, they're obviously on, and red means they are not. Then you have the pushers. So these are the cylinder position switches on the pneumatic pushers, and obviously if they're green they're true, and if they're red they're false. So now I'm going to go log in as the supervisor. That is a capital S in supervisor and a capital S lowercase up for the password. So an abbreviation for supervisor. The only thing that the supervisor can do that the operator can't is see the alarms. So that's what this page is here. If there was an active alarm, it would show up in this spot here. So I have a couple different alarms. Obviously, there's the alarm if you move the block out of the track, if it gets pushed off, stuck somewhere, and it keeps running. It will, if it's not returned past the inductive sensor in a certain amount of time, it will fault out, which is what I did right there. And then I also have other ones, which if the pneumatic cylinders don't return to resting position in a certain amount of time, you will also get another fault. So that's what happened with those faults. So then what you can do, obviously you have to reset your machine fault, which you can do in the HMI just like you can in the physical. You set it to off and then hold the stop button for 3 seconds and it will reset the fault. And then you can just start it back up again and it will be good to go. Obviously, I placed the block back in its position because to get it to fault, I moved it out. And then I'm going to switch back to janitor mode here because I don't want it to have all these permissions when I leave. I could have also just done log out and it would have got rid of those permissions. And that is going to wrap up the video. Thank you for watching.